morning, everyone. So today we'll talk about Angular Dependency Injections and how to use that to implement something called processor patterns. Okay, so this is a little bit about myself. My name is Jecelyn. I live in Malaysia. So if you know, Malaysia is in Southeast Asia. It's about 16 hours flight away from Germany. So I'm a GDE for a Google Developer Expert for Angular and web technologies. So after these sessions, if you have questions on Angular, we can discuss as well. Okay. And currently I work as a software architect in Randstad. So if I think Randstad is a HR company. So if you heard of Randstad, if you're not, then there's a company called GULP, G-U-L-P, GULP DE in Malaysia. So it's in Germany. It's a child company of Randstad as well. Okay. So that's me. All right. So this is the agenda for these sessions. First, we'll talk about dependency injection in general, but I think we can go through this pretty fast because most of you have been using Angular already. Then we'll talk about DI in Angular, processor patterns, and how to do that in Angular. Okay. Let's start. So let's talk about dependency injection. What is that and why do we need that? So let's say we have a ninja and the ninja needs a weapons and the weapons is made by material. So if we convert all these to programming, probably we have a class called material and we have a class called weapons, and the weapons will have properties called name, and because we need material, so in the constructor, we actually put that in because we need a material when we create the weapons. And then for our ninja class, when we create a ninja class, the ninja will have a name. And for the weapon, we need to instantiate this. If without dependency injections, this is how we need to instantiate that. Okay. So, but this is not very good because if we follow the programming principle solid, this is violate the single responsibility because the ninja actually know too much about weapons. It's not supposed to know the material of the weapons because ninja only cares about the weapons. And it's actually tightly coupled because you couple the ninja class with weapons and material. And this make it a little bit hard to unit test. Okay. Then with dependency injections. So yeah, then we don't need. So for the ninja class, we actually don't need to instantiate that weapons in the ninja. We just inject the weapons class in the constructor. And then for the weapons, it's the same. So we put the material in the constructor. And then we have the material class. Then we have somewhere in your applications, we'll need to hook up the implementations for the class. So for example, we will have something like this, like provide weapons and use the weapon class. And for material, please use the material class wherever someone called it in the constructor. Okay, this is dependency injections in general. Okay, so the benefit of doing this is we can replace the implementations under the hood. So for example, we can change now the weapon class, I want to use dart instead. I don't want to use the nunchucks as the weapons. I want to use dart. Then we can change the implementation under the hood without changing our code. Okay. So with dependency injections, it makes things unit testable and it's increased the reusability and it's basically loosely couple your class with the implementations, and it's follow the D concept because we're applying dependency inversion principle. Okay. So DI in Angular. So if we convert the ninja to Angular, so probably we'll have something similar to this. We'll have a ninja component because this is what we want to show in the page. Then we'll have a weapon and material as a service. So we put that as injectable. Then in our module, we will link that up. We will provide the implementations. So for the weapon service, we'll use the class called weapon service. For the material service, we'll use the class material service. But normally, we don't write. So this is the long syntax. But Angular, because Angular is good, so it gives you a shorter syntax. So this is normally how we define the service. We just put weapon service and material service. But you can actually do that. Okay. Beside use class, you can actually use value, use factory, or use existing. So we won't be going through all the ways of using this, but if you are interested in providers dependency injection in general in Angular, you can go to the link. Alright. So now, dependency injections is static. What do I mean by static is, so let's say this is your component. Now we have the weapon service injected in. So we can only hook it up once. So we cannot change. So what if now I want to change the weapon service to that service dynamically? There's no way for me to change the implementation dynamically. So what if I have our Ninja need to switch weapon dynamically? So for example, I want to do something like this. I have Ninja. Can I zoom in? I have a Ninja. That sword, stick, nunchucks is all different services. I want to change it dynamically when we run the applications. So this is where we can use something called processor patterns with Angular DI. Okay, so this is what we want. This is what we want to achieve. So we inject the weapon service, and then based on the weapon name that we pass in, we can call the same. We can call the same method draw and animate, but we just inject for one time. Okay. Okay. So let's summarize this one. So basically, we need a weapons interface. That interface have a property called name, have a method called draw, and have another method called animate. And then we have 4 different classes that implement this interface. After that, we inject these 4 services, but we inject only for one time. We inject to the Ninja component as a weapon array, so that later on we can change it. So this is the weapon interface we can achieve with something called injection tokens in Angular. We can create one injection token, and then we'll have the different 4 classes, the implement classes. We call that processors. Then the injections, we can use multi-provider to achieve this. Let's look into the code. So in order to create an injections token, Angular provides us a method. So we just get the injection token. Then this is how we create the injection token. Okay, so we have a weapon processor token, and then we provide what is the interface for this token. So in this case, I create an interface called weapon processor, which has the name, draw, and animate. Then for the name, so currently because I have 4 names, I want to strong type my name. That's why I create a type, weapon name, so the value can only be sword, dart, stick, or nunchucks. But this is, so for the name, because of I want to strong type, so I created this. But if you don't want to strong type it, you can just assign string for the type. It's definitely fine. Okay. So after we have this token, then we need to implement the weapon processor. So for the sword, this is one of the sample implementations. So I have a class that implement the sword weapon processor. Then I assign the name as sword, and I have some logic for drawing. I have some logic for animate. So the same thing I will implement for the others 3 weapons. All right. After that, this is how we hook it up. So we can say that. So we provide. So let's take a look into this. So we have 4 providers, but the 4 providers actually using the same token. Can the backs look? Is the code okay? Can you from the far? Can you look at the code? Okay. All right. All right. So you can see that I import the 4 different class, sword, nunchucks, stick, and dart, but then I provide it to the same token. Weapon processor, all are weapon processor token. And then I give in one more properties called multi-true. This is you are telling the Angular Dependency Injection engine that we have multiple implementations for the same token. Okay. After that, what we need to do is, in the normal way, when we inject that, we don't have this alias. We didn't use this alias inject, but because this one is like we use the same token, but we have multiple implementations. So what you need to do is you need to use the decorator alias inject, and you pass in the token. In this case, is weapon processor token, and then this is the expected output, because we are expected 4 different processors in our case. So by doing this in your weapons, you actually get 4 different implementations. Then during the runtime in the switch weapon methods, you just need to find the weapons by the name. So when you click the button, you pass in the name. You just need to change the name, and then you can call the functions using the same method, draw and animate. So probably this Ninja example is not very practical, because in our real life programming coding, we rarely write something for Ninja, but we write for the business. So let me give you an example that we use, how we use that patterns, wherever we talked just now, in productions. So in our case, we use these processor patterns, so the same interface but have multiple implementations for our chart. So this is how our dashboard looks like. So in our dashboard, we have a lot of different type of charts. Okay, and these different type of charts, the way the logic that how we group it and how we come up with the data is different. How we process this is different. And here are some of the differences. So the chart, definitely the type of the chart is different. So we have pie chart, we have bar charts, and then we have others charts as well. And then the title and the menu is different. So you can see that if it's a bar chart, then we have this view and export line menu and actions. But if it's a pie chart, we don't have that. And the labels and the tooltips is different as well. Some of the labels is like just one label, but some of the label contain more informations. Okay, but there are also something that they are similar. So because they are all charts, and normally when working with charts, we are using chart library to draw the charts. Okay, and then they have a similar interface, which because all of them have name, all of them have title, and all of them can have functions called process data. So this is the similar interface that they have. So by having this similarity, we can implement processor patterns for each of these charts. Okay, so let's take one of the charts for example. So this is a chart that calculates how many new starters every month. Okay, so this is what the user want to see. The user want to see the month and the year in a sorting format. So start from June, July, August, and forward. And then, but this is what the backend return to you. Okay, the backend return you a date, and then so that basically return you a daily data. So you can see that in August it return you 2 lines of data, and they return you the formats in YYMMDD. So as a front-end developers, probably you will ask, why can't the backend give you exactly what you need? Then you can convert it easier. You don't need to do the grouping logic in your front end. But this is normally happens. So sometimes when front-end developer look at this, oh, can you give me something that more suitable for the chart? Then for some reason, probably you cannot get it. So this is something that you do in your process logic. Okay? And some more, your chart library actually want different format. So if you have been using Chart.js or D3 chart before, probably this looks familiar to you. So so in order to generate the bar chart just now, this chart, okay, this is how the chart library wants the data to be. So you need to bind to the chart element, and for the data you need to pass in what is the type of the charts, and for the columns you need to pass in there needs an array inside an array. And that array, the first item in the array is basically the label that you need. And then the data. So then the axis X and Y, you need to pass in as well. And the date. So basically you need to, this is what you need to do. You need to transform the data, loop it, and group it by the year and month. And then sort it, and then generate the chart configurations. Okay, that's a lot of work that you have to do as a front-end developer. Okay? So this is what you actually do. So we have, so let's say we have a chart processor. So this is one of the implementations of the chart processor. So we pass in the name. So the chart name, we just give it a name called new starter. And then we give it a title. And for the process data, because the process data is the standard functions that for the chart processor, so we implement that. Then in here, we just split out our functions. So we just get the data, and then we have functions to transform the data, and then we have another functions to draw the chart. Okay, but bear in mind, if you see that the get data, transform data, and make charts functions are all private, because this these three functions is specific to this chart. For this new starter charts only. It's not necessary that you need to split it into a different functions, because wherever the chart processor care, we only care about the process data. So, so all the internal code depends on you, like how you want to split it. That's why we put that as private, because we won't call these functions outside of this class. Okay. Okay. So then, by doing this, then we can, so this is the example, this is how the interface looks like. So just now we have the chart processor, name, title, and the process data. So we just pass in any type, because the type, we actually not sure like what is the process data will return to us, because different chart will have different data that passing in back. Okay. Then in the same thing, we just provide the charts processor tokens with different charts processor. After that, in our UI, what we do is, so normally the charts, how we display the charts in the UI is based on user permissions and the rights they have and their configurations. So for example, normally you have a list of charts that you want to show for user A, and you have another list of charts that you want to show for user B. And this data normally come from database if you store it. So then, so for this, during ng on init, probably you get the list from one of the API. After that, for each of the name of the chart that you should show, you just loop through that, and then you find the correct processor of the chart, and then you just call processor.processData to actually process each of the chart and get the data, and then assign it to the charts array. So by this, then you have all the charts data that put in here. Before implement this pattern, we actually have one big service that have a lot of different functions. So for example, for the first chart, we'll have get chart A data, and then we have another function called get chart B data, and then we have another one called get C and D and E and F. So we have about 30 charts. So the service itself contains like 30 different functions, but every one is like calling and processing the charts. By implement these patterns, is for each of the chart is basically one class. So, and then the name of the functions is actually similar. So it provide developer a better way, a predictable way, because wherever you create a chart, this is what you need to do. You need to implement the processor and then write the logic that how do you want to process the data. And this actually this is actually good for our unit test as well. So we just unit test each of the processor to see whether the data return is correct. Okay. And these are others useful scenario probably you can consider to use that patterns. So some people actually use it for data table processor. So for example, in your application, probably you have a lot of page that display different grid. So probably you have a list for the customer, you have another list for orders, you have another list for something else. So for all these lists, probably the grid or the data table library that you are using, for example, grid, probably the logic that you define the data table object is quite similar. So probably you can have implement this pattern for different table. You implement different processor, and then you have the you just process the data table and then bind it to your component, or just your component you call it and then implement that. So it could be used for that case, or you can. There are people that asking whether can use for search processor as well. So in that case, I actually answer one of the questions in Stack Overflow. You can click on the link to know more. So this person actually have a search bar. So the search bar in page A is search for books. The other page is search for another product. So they have the similar implementations, but the search logic is slightly different. So he actually used the processor patterns to implement like 2 different implementation, but using the same token. Okay. Okay. And the benefits is, like we say just now, is the abstractions, and you can create something like because each of the implementations is like a plugin itself, so it's make your code more maintainable. Okay. And this is something more. Any one of you use NGRX or in your projects? Okay, so for those of you who didn't use or haven't heard of NGRX or NGXS, this is a state management tools for your Angular applications. Okay, so if you not very sure about the NGRX, you just treat this part as additional information for you. So we can combine the processor patterns with NGRX. So this is how you can do it. So you have your so you have 3 actions. So you have a get chart action. You have so you have after that, when you call the get chart actions, you can have 2 states. It's either success or fail. Okay. So this is how your function. This is how your reducer looks like. So we have so let's look at this interface. This is our state. Our state is we have something called a charts property, which is an object. So the object will be the charts name, and then the value would be the charts data. So every time, so after we just replace the data in our charts object. So if it exists, then we replace it. If it's not, then we append to the chart object. Okay. Then we have, this is the effects. Basically, the effects is calling the is what we use to call the charts data and process it. So in here, when the UI pass in, like for example, I want to get the data for charts A, then this is the function that we'll call. You will just get charts, and in here, what we are doing is we check that whether the charts is already exists in our current selector, in our current state. So if it's already exists, then we don't call it. We don't call the API to get it again because it's already exists. But if it's not exists, then first we get the processor, we get the correct processor, and then we run the processor logic to process the data, and then we append the data to the chart state. Okay. So in here, the final line, we just either get the data from our cache, which is our state, or from the API. Okay, so this is how, after implement NGRX, this is how your charts, the charts component will be like. So so we have a charts observable. Okay, then for the charts observable, basically we just slice the what we do, we just slice the data from our state, saying that we want to select the charts object, and then we just change the chart object to an array, so that we can show that in our template. We can just loop and show each of the charts in our template. And when we want to get the charts, then we just call the store to dispatch the actions to actually check whether the charts is already in the state, or we should get that in the from the API. Okay, so let me show you the difference. Okay, so this is the chart demo. Okay, let me change that to the network. Let me change to like the slower network so you can see the difference. Okay, fast 3G. So this is the chart demo. So if I refresh, so it will call the XHR. So you can see that it's actually called the we will call the API to return 4 different charts, because in the UI I have 4 different charts. So without implement the NGRX, so every time it will call the API, it will call the network to get the charts. But if with NGRX, so this is the first time I call, so it will call the API to get the data. But if I go to other page, and if I go back again, you can see that there's no data loaded, because it get that from the store. And then you can see that the charts immediately just draw it out. But if I click to chart demo, which I don't use the NGRX and I didn't implement any cache, you can see that it's actually called the server again to get the data. Okay, this is one of the benefit if you are using NGRX. Of course, without NGRX, you can store the data in your sessions or in your local storage. But yeah, you can, if you are interested, you can actually try NGRX. Okay. All right. So so I have put up the demo in this link. Okay. So we are done. So basically, I think processor patterns helps in our project. Not sure about you, but if you have a similar issue like my company did, then probably you can try to use this pattern. And this is the link for the slide, the demo, and the code. Okay, thank you.